This program will help you learn about scuba diving. Although it can supplement training, it cannot take the place of a complete training program. Responsible participation in recreational scuba diving requires that you demonstrate the necessary knowledge and skills and be evaluated by a qualified NAUI instructor. Before beginning this program, take a moment and prepare to fully utilize the NAUI education system. You can do this by getting the textbook, a notepad, the NAUI pen and pencil set, and the workbook ready to use. When you see the Take a Note icon, stop the program and jot down the information. It forms the basis for the final test. When you see the Open Book icon, stop the program and complete the corresponding questions or exercises in the NAUI workbook. It is also easy to refer to the textbook as the same icons appear there and point to the related and highlighted text. In this way, you'll master the information faster and you'll perform your best in the water sessions and on the final written exam. NAUI Worldwide, the National Association of Underwater Instructors, presents Master Scuba Diver, a comprehensive video that describes in depth the gear and skills you will need to become a NAUI Master Scuba Diver. Chapter 1. Diving Equipment. As a certified diver, you are familiar with the basic equipment used for diving. As a NAUI Master Scuba Diver, you need to know more about the equipment you use and the equipment you might want to purchase. There are three categories of scuba: open circuit demand, semi-closed circuit, and closed circuit. Open circuit demand scuba is the most commonly used by recreational divers. A scuba system where the breathing gas is inhaled upon demand from the breathing apparatus and exhaled directly into the water is called open circuit demand scuba. Scuba cylinders are made of steel or aluminum, and there are different metal alloys of each type. They are manufactured in different physical dimensions and capacities. Every high-pressure cylinder has markings stamped into the metal on its shoulder that provides valuable information. In the U.S. system, service pressure is given in pounds per square inch, and the stated capacity is the volume of air which the cylinder contains when it's fully charged. For metric European-type cylinders, pressure is given in bars, and the measured capacity is the actual internal volume of the cylinder. The test pressure marking is the pressure to which the cylinder is subjected during hydrostatic testing. For a 200-bar cylinder, it is 300 bars. For a 232-bar cylinder, it's 348 bars. On steel cylinders, you might find a plus sign after a test date. If this appears, it means that the cylinder may be overfilled by 10%. It is important to keep moisture out of a cylinder. Water will cause corrosion. In a steel cylinder, this corrosion is called ferrous oxide or rust. In aluminum cylinders, it's called aluminum oxide. A serious problem, in addition to corrosion, can result from the prolonged storage of air in a steel cylinder containing water. The oxidation process will, over time, consume some of the oxygen in the air, leaving a higher nitrogen concentration. To prevent moisture accumulation, always maintain about 20 bar or 300 psi of pressurized air in your cylinder. If a whitish mist is detected when the valve is opened, if sloshing can be heard when the cylinder is tipped back and forth, or if the air has an odor, do not use the cylinder and have it inspected as soon as possible. All scuba cylinders should be inspected externally and internally by a qualified professional at least once a year. If internal inspection reveals corrosion in a scuba cylinder, it may have to be cleaned by tumbling. The process involves filling the cylinder approximately half full of an abrasive material and rotating it for a number of hours. The standard on-off valve is known as the K valve in the USA. The J valve contains a spring-loaded check valve that begins to close when cylinder pressure reaches a predetermined pressure. When the lever is manually depressed, the remaining air becomes available. J valves are not very common today. A dual valve for a single cylinder, known as a Y valve or an H valve, allows divers to mount two regulators on a single cylinder. Another type of valve that is becoming popular is the DIN valve, which is common in many countries outside North America. This allows a thread-on attachment of a regulator to cylinders using higher working pressure. High-pressure air from your scuba cylinder is reduced in stages to ambient pressure. Nearly all regulators are two-stage devices. The first stage reduces cylinder pressure to an intermediate pressure of approximately 6 to 10 bar or 90 to 150 psi. The second stage reduces air to ambient or surrounding pressure. To understand the operational theory of a regulator, you need to be familiar with the types of internal regulating valves used. The fundamental types are downstream and upstream valves. A downstream valve opens with high-pressure airflow. An upstream valve is one which opens against the high-pressure